Hello, I'm Edmund Penning-Rowsell from the Flood Hazard Research Centre at Middlesex University. We've been studying environmental management and natural hazards since the early 1970s. Today, we believe our research has never been more relevant, as many communities across the world are struggling to cope with record flood levels and the vast damage that follows. Our aim is to help communities and governments to reduce the risk from natural hazards and improve policies for current and future generations. We work to promote sustainable water and coastal management, policy and practice based on good governance. Our centre is an interdisciplinary one, based on the School of Science and Technology at Middlesex University. Our academics and research students specialise in the interaction between people and the environment, as well as the environment policies that are so important. Our base is the UK, but we've worked in all countries over the world to try and promote better risk reduction. And to that end, we've published a number of technical manuals over the years based on sound economics to justify investment in flood risk management measures. Why? We seek sensible decisions on where and when to invest our hard-pressed taxpayers' money on reducing the risks of flooding. Our contribution to the Flood-CBA 2 system has been developing a common framework of terminology, a set of guidelines and pro formas, and an Oxford demonstration case study. That's our contribution to this particular research and development project. So, what about the Oxford Flood Alleviation Scheme? This is a demonstration case study. Here's Oxford with its famous university and a wonderful city. But the city has a flood problem. The city itself and the university is to the right of this diagram here, but in the floodplain we see many different properties, industrial properties, commercial properties, residential properties. This is the flood of 2007, which affected the city very severely. And here's some examples of the kind of impacts that that flood has had. 2,000 homes affected, 200 businesses flooded, nursing homes evacuated, a big clean-up operation, schools costing £632,000 to repair and reclaim. And very importantly, tourism bookings down by 40%. Quite a significant effect on the actual city and its economy. Quite a serious impact, something we need to try and counter, try and reduce with our investment in the future. So here is the floodplain, the map of the floodplain in Oxford, and here you see individual properties being assessed with our damage assessment technologies and our methodologies in terms of the impacts that future flooding will have. Where are they? How can they be flooded? How can we reduce this flooding in the future? Here's another example to the west of the city where there are a number of hotspots, individual properties where the damage potential is very high. We need to try and reduce this damage so as to make life for people and their property more acceptable, reducing the risk, reducing the trauma and problems that come with flood events of this magnitude. So what is being proposed? Well, what's being proposed is a 5-kilometre new channel bypassing Oxford, taking the floodwaters downstream. It's going to cost a great deal of money, 140 million euros of investment on this particular flood channel. A very serious decision, one we need to look at very carefully. It's going to take time as well. It's not going to start production, it's not going to start construction until 2018. But that doesn't matter as long as we get the economics right, as long as we get the design right. That's our objective in this particular Flood-CBA study, to look at that decision. The bypass channel will take the flood waters from just west of the city and the university and discharge them way downstream below locks which control the flood waters now. That's the idea, that's the concept, that's what we've been studying. And here is a diagram summarizing the economics of that particular decision making. What we have here, what this means is, first of all, we're looking at the do-nothing situation. Let's assess the economics of doing nothing. And that shows that it actually is a huge amount of flood damage, huge amount of problems in the future, especially as climate change ramps up the flooding in the future. The first option is to continue with the existing maintenance. It's quite a good maintenance regime. It does stop quite a lot of flooding. It doesn't stop the major events. That's the real difference. The second option, option 2, is to do more maintenance and selected local intervention works so that we can actually solve some of the problems in some parts of the city, but not everywhere. And the third option is this bypass channel, which I've described already. And the economics of this are very favourable indeed. This is what we're analysing in Flood-CBA 2. The economics shows that there's a really good return on investment, a benefit cost ratio of 7.92, and even an incremental benefit cost ratio of 1.24. Those are technical measures designed to show that the investment in that flood risk management scheme is really worthwhile and a really beneficial effect on the city, its university, and of course its traditions. So those are the figures. Those are the figures showing the incremental benefit cost ratio, and that's the kind of contribution that we are making to the Flood-CBA system from Middlesex University. Thank you very much.